Okay, so you guys are going to be taking notes on just properties of parallelograms so that you guys can be ready to do the next 5 or 6 sections. Do me a favor, and when you get to the notes that look like this, there's say 572 notes day 1, pause the video and then write down all of this writing that's in here. This is the definition, and then 1, 2, 3, 4 additional properties because it's a parallelogram. And then once you're done writing down all of this, then unpause it, and then we're going to label our diagrams to the right. Okay, so go ahead and pause it. Okay, so the definition of a parallelogram is very simple. It is that you have a figure, a four-sided figure, so a quadrilateral, that has opposite sides parallel. If that happens and you have a figure with opposite sides parallel, we call it a parallelogram. And because it's a parallelogram, you get 1, 2, 3, 4 additional properties. One of them is that, well, actually, let's label the diagram and show that it's parallel. So in order to show parallel, we show that this side is parallel to this side, and then we show that this side is parallel to this side. If you guys remember, those are the symbols for parallel. Opposite sides are congruent, so that means that this side is congruent to this side. That would mean that this side is congruent to this side. So you guys should be labeling this. Okay. Opposite angles are congruent would mean that this angle is congruent to this angle. It would mean that this angle is congruent to this angle. Okay. Consecutive angles are supplementary. Consecutive means that when we go around our figure and we go from here to here to here to here, so if we say that this is parallelogram A, B, C, and D, consecutive means we go from A to B or A to D, but consecutive would not be skipping B to go to C. So if consecutive angles are supplementary, it would mean that angle A plus angle B equals 180. So right here, why don't you write the measure of angle A plus the measure of angle A plus the measure of angle B equals 180. We could also say that the measure of angle B up here, if instead of going backwards to A, we could also go to C and say plus the measure of angle C equals 180. Okay? And then you have another property over here that says that diagonals bisect each other. So diagonals are when you go from one side of your vertex to the other. Okay, and bisects means that that would mean that this diagonal right here was cut in half. So that means that this piece is congruent to this piece. And because then this one was also bisected, it means that this piece is congruent to this piece. So it means that if this is 5, then this has to be 5. But they're not all 5. If this was 7, then this would have to be 7. So they bisect each other. So this longer one was bisected and this short one was bisected. Okay? So pause it if you need to go back. And then if you look down at the bottom, you have that we have 3 special parallelograms. Special means that they have additional properties besides those 5 properties. Our special parallelograms are a rectangle, a rhombus, and a square. And we're going to talk about a rectangle first. So go ahead and pause it and then write down the definition of a rectangle and then that the diagonals are congruent. Okay, so you should have that written down. The definition of a rectangle is that, first of all, it has to be a parallelogram. And then what we're saying is, to be more specific, not only is it a parallelogram, but it's a parallelogram with 4 right angles. So if we have our figure here, we show that we have this, we have this, we have this, and we have this. So this still holds the properties of all of that the parallelogram has because it is a parallelogram. It's just, in addition, it has 4 right angles. So it still has opposite angles congruent, it still has opposite sides congruent, it still has consecutive angles supplementary because 90 plus 90 is 180. It still has that diagonals bisect each other, but an additional property of a rectangle is not only do the diagonals bisect each other, but because this is a rectangle, they're actually congruent. So if we label this parallelogram, a rectangle, as ABCD, it would mean that segment AC is congruent to segment DB. Congruent. They do bisect each other. So what that means is that, if we say this is E, if AE is 3, because this AC was bisected, then this also has to be 3. But because the diagonals are congruent, that would mean that DE is also 3 and EB is also 3. So you can see all those are congruent pieces, unlike up here where they weren't congruent. Okay? What that means then is that this is congruent to this, which is congruent to this, which is congruent to this, and believe it or not, that means you have an isosceles triangle. If we look at this triangle right here, we have two sides congruent. These are your two congruent legs, and then that's your base, so an isosceles triangle. So that means that this triangle is isosceles to this, which actually means they're congruent. And then we also have that this is an isosceles triangle because that side's 3 and that side's 3. And then this triangle is congruent to this triangle. So lots of properties. So that's what we're going to lead into with proofs. Okay, so pause it if you need to, go back and label. All right, a rhombus is another type of special parallelogram. So what it means is that it's a parallelogram, but not only is it a parallelogram, but it has 4 congruent sides. Unlike a parallelogram, it's just opposite sides congruent. Okay, so pause this and fill this in, and then unpause, and then we'll go through and we'll fill out the figure together. All right, so a rhombus is a parallelogram, but what we're saying is it's actually more specific. It means that all sides are congruent. So not only is this side congruent to this side, but it's also congruent to this side, which is congruent to this side. So it's a square basically, but it's like pushed over because these are not 90-degree angles. So if this is 10, then this side is 10, then this side is 10, and then this side is 10. Okay? The other properties still hold. You still have opposite angles are congruent, so this angle is congruent to this angle is opposite and congruent to this angle, so you still have all those rules. Another property that you have is the diagonals in a rhombus are actually perpendicular to each other. That means when you draw your diagonals, perpendicular again means 90, so that means that all 4 of these angles are 90 degrees. So that'll just be other properties that we can then set up. We also have that if you draw on the diagonals again, that they bisect the vertex angles. So what that means, sorry, that's really squiggly. What that means is whatever this angle is congruent to this angle because it was bisected by that diagonal. And then remember, opposite angles are congruent, so that means that this angle is congruent to that one, and it was also bisected. So those are 4 congruent angles. We also know that over here that this angle is congruent to this angle because they're opposite angles, but because it's bisected, we now know that this angle is congruent to this angle, which then means that these 4 angles are congruent. Okay? Alright, so let's fill in some numbers to actually help you out here. So let's say that this big angle right here is 140. If it's bisected, that means that this one's 70 and this one's 70, which means then these are congruent, and then this would be 70, and then that would be 70. Okay? Let's say that this angle over here is 80, which would mean that this is 40, and this is 40 because it was bisected. And then if that's 80, this angle is also 80, which was bisected, so that means that these are all 40. Okay, now, if we look at the fact that these are triangles, so here's a triangle. Triangles sum to be 180. So that means if this is 70 and that's 40, 70 plus 40 is 110, which means that there's 70 degrees left for my triangle. And by vertical angles, this is also 70. Actually, sorry, I'm going to go ahead and erase all those angles. Sorry, I forgot that this has to be 90 degrees. So if these are 90, let's go back and we'll leave this one right here as 70 and 70, which means that these are also 70. But then we need to take into account that if this angle is 90, so if we're looking at this triangle, so this angle is 90, so 90 and 70 makes 160, which actually means there's only 20 degrees left here, and there's a congruent, so those are both 20, which means both of these are also 20. Okay, sorry about that, so change those 40s to 20, so 20 and 70 makes 90 plus a 90-degree angle. All triangles now sum to be 180. Okay, alright, last special parallelogram is this square that hopefully we're the most comfortable with, but there's actually a ton of properties that go along with it. So the square, if you need to pause it, go ahead and pause it and fill in all 3 of these things. A square is a parallelogram, but not only is it a parallelogram, it's a parallelogram with four congruent sides, like a rhombus, so label it all four of those are the same. And not only does it have four congruent sides, but it's like a rectangle, and it has four 90-degree angles. So it's the most specific parallelogram. So like a rectangle, it has four 90-degree angles, and like a rhombus, it has four congruent sides. So it's kind of a rhombus and a rectangle put together. Okay, so now, because of the fact that it has all these extra properties, it has three things that happen with its diagonals. One of them is like a rectangle, the diagonals are congruent to one another. So if we label this as square ABCD, that means that we could say that segment AC is congruent to segment DB. Okay? We can also say that if this is a diagonal, and this is a diagonal, like a rhombus, the diagonals are perpendicular to each other. So that means that all four of these angles are 90 degrees. Which in a square means that if this side, so if we think about writing proofs here, if this side is congruent to this side, and then this is bisected, so if I look at this triangle right here, I can see that it's bisected. So that means this segment's congruent to this segment, which means this segment's congruent to this segment. All four of those are now congruent, and we know that this side's congruent to this side. We can prove that those triangles are congruent by side, 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 or by side, angle, side, because vertical angles and they're both 90. So we'll be using those properties. Okay, and then last thing, we can say that the diagonals bisect the vertex angles, just like in a rhombus. So if I draw my diagonals, and I know that here's a vertex, this is a 90-degree angle, and if it's bisected, then that means this has to be 45 and this has to be 45. And because this is 90, this is also 45 and 45. And because this is 90, this is 45 and this is 45. And because this is 90, this is 45 and this is 45. Okay? Remember that if you have two congruent angles, it means you have two congruent sides. So those sides are congruent. So we now have an isosceles triangle, which means that this triangle is congruent to this triangle, which is congruent to this triangle, which is congruent to this triangle. So all four of these triangles are actually congruent to each other, and we'll go through like the proof of that. So if you need to go back and re-record anything or re-listen to anything or write down anything, go ahead and write those down. You're going to use all these properties in the next couple of days in everything that we do. We're going to do algebra problems, we're going to do proofs, we're going to set up equations. Okay, the better you are at knowing all these properties, the better chance you have to set up the right equation. Okay, thank you.